Hello, everyone. Today we're going to discuss the air bench that we have in the thermofluid lab. The air bench is meant here to provide a simpler wind tunnel configuration. As you all know, we have the main wind tunnel we have in the lab here. That's the blue one. It's meant to be educational. It gets a little bit tricky to use this with a very consistent data just because of the fact that it takes calibration and so on. So for the case where we have a lab that are set up for us, we actually use the smaller version of the wind tunnel. So the air bench, it's mainly a blower that you see on the bottom with the red color, which is similar to a fan, and that fan provides low pressure behind it, or actually pushes the air to on the side. If I go here around, so the air in that case sucked from the outside, pushed upwards all the way to the top, and in this reservoir here where the flow started to be settled, because we have a honeycomb structure as well as the venturi that you see there, meant to bring the flow to a laminar state as it goes through the module that you're trying to use. This air bench can work with multiple experiments, and most of the time in our case we use a Bernoulli module that you see right here, and we'll discuss it in different video. We also have the boundary layer module, and very commonly too we use the aerodynamic module. Okay, and that's meant to measure the drag force. Okay, how you operate the air bench? The air bench, after you plug it in, which I did, you can turn on the machine here to the on button. You bring it on and should start at 0 value first. So we could make sure to start it from 0 position. Right now it's exactly at 0, so you don't have any flow rate. And you hear that very low noise level. So how you see the 0, when you have 0 on the outer dial right there, and also 0 in the inner dial. So the inner dial takes full rotation, the one that is represented by a very small value there, like with a small window, full rotation to get to 1. And 1 here corresponds to 10% of the power of the machine. So every 1 revolution will give you 10% of the machine. This is obviously associated with the speed of the flow, but doesn't tell you how much is the speed of the flow. You will learn it in fluid mechanics class that the speed of the flow depends on the cross-section area. So it really depends on where you are in terms of the machine to determine the flow speed. And that's something you're going to measure with this machine. Most of the experiments are run above 50% of the machine. So you can see now I'm getting to 30%, whether you can see it very clearly or not, but hopefully you can. This is at 3 on the top and 0. So for example, 35%, would be a value of 35%, at 3 on the top and 50 on the dial that you can actually rotate. Okay, you have an emergency button here. This has to do with the smoke machine, which we don't use it in these experiments. It's used mainly for demonstration. So you're really working right now with 4 buttons. This one to turn it on after you plug it in. This is on for the fan. This is on for the electric connection. And then you started to move the dial up and down based on the value that you want to set the experiment on. This is an emergency button. If you push it, you get the machine to stop in emergency situations. We use safety glasses with this specific experiment. There's a moving air, so we want to avoid any debris, so we always try to get your safety glasses on to start to work with this experiment. These also equipped with a manometer. This is 16-channel manometer for pressure measurements. And those pressure measurements later on can be converted into velocity measurements if you use Bernoulli equation and Pettit tube equation to actually have these values. This video meant to be part of the introduction to the experiment. So you're still going to work with your instructor to make sure to understand what are the objectives of each experiment and so on. So we're not going over a specific experiment right now. We're only introducing the air bench. The 16-channel manometer, you connect to the lines that you would like to use. You don't have to use all of them. At this point, you start to see most of the lines having exactly the same level, which is the one that is connected to the atmospheric, because it just measures atmospheric pressure. The one that has the machine connected to right now, and you can see 2, 3, and 5 are being connected, you're gonna see small fluctuation. The speed is low, but if I actually increase the speed a little bit, you're gonna start to some change on the water level that actually relevant to the speed and the pressure at every point of measurements. So we can see it's at 2, 3, and 5. Actually, we only connect right now for this case 2 and 3 that are the ones that are connected right now. 5 is not, but it's ready to be connected if you have the reason to do that. Okay. Though we want to make sure to be able to read these values. You can increase the sensitivity of the manometer by kind of incline the manometer, and you can see here the set positions of inclination to kind of a snap on to the new condition that you have. The ratios of each level given here, you have 1 to 2, which is common to use 2, and you can go all the way to 1 to 10. This is bring it almost to a very flat surface, because 1 over 10 is actually the sine minus 1 of the angle that you have, and you're going to see that this angle becomes a very, very small, almost a flat surface. That's mainly increase the sensitivity, so you can read smaller changes better, but also decreases your range of measurements. So instead of measuring all the way from 0 to 36 centimeters, you're going to decrease this by 10 times if you do it 1 to 10, or by 2 times if you use 1 to 2. So we normally use it vertical as long as the pressure differences are big enough to be seen from one case to another case. Okay, with this you have a good idea about how to use the air bench, how it's constructed. In later videos we're going to go over a specific module and a specific experiment. Thank you.